Okay, so I want to see two functions are inverse of each other or not. So I want to see if the graph of two functions they are symmetric to one another or not. Okay, so and we want to compose those two functions together. Okay, to see if it turn out to be x or not. If it turn out to be x, then they are inverse of each other. Okay, so given two function, okay, f and g, okay, and f and g are inverse of each other when, okay, they are inverse of each other when, okay, f composed to g, you remember this symbol we already learned, FOG, f composed to g, okay, turn out to be x, okay, and g composed to f, also turn out to be x. Okay, so we need to check both these both conditions here. We do FOG and GOF. If they are the same x, they turn out to be the same x, then we know they are inverse of each other. Okay, and then we know that they are symmetric about the line y equal x. Okay, but it must be the same x. Must be the same. It cannot be x squared. It cannot be x to the third power. It must be the same x. Only x. Okay. Let me give you an example. What if I have two functions? Okay, and I want to see they are inverse of each other or not. Example 1. Let's see. Okay. I have two functions. The first function is f of x equal to 100 plus 12x. Okay. And g of x equal to x minus 100 over 12. Okay. So I have two functions and I want to see they are inverse of each other or not. Okay. So I compose f to g and we see if it turns out to be x or not. Okay. Solution. F composed to g. I don't know if you guys remember how to do this. F composed to g, it means that you plug g, you have to go backward. You plug g into the x of the f, right? So put this one here in here, so I have 100 plus 12 times x minus 100 over 12. Cancel, cancel. Here you go, I got x. Now, I do GOF. Okay, GOF. I mean, you plug f into g, so the whole thing in there, so I have 100 plus 12x minus 100 over 12. Cancel, 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 cancel. Here you go. So both of these, FOG and GOF, it turned out to be the same x. Then we can conclude f and g are inverse of each other. Okay. Alright. So after we know the condition for two functions are inverse of each other, then we also know that the necessary condition for a function to have inverse must it must be a one-to-one function, right? Okay, and graphically, the graph of the function must satisfy horizontal line test. That's considered as the condition 2. Okay. Then afterward, we want to find the inverse. After we know that they have inverse, then how are we gonna find the inverse? Okay. So on the fourth part, okay, I want to find inverse of a function. Inverse of the function. Well, actually, I should try find inverse function of the function, because when we're talking about inverse, they are a function also. Okay. So how are we gonna find inverse function of the function? Okay. After we know that that function has inverse, how are we gonna find it? Okay. Example. You just need to follow a certain step. It's nothing hard, because there is a rule for that, so you just follow the rule. Okay. What if I have a function like this? F of x equal to 3 minus x, okay, over x plus 3. So I have a rational function like that. And I want to find the inverse function of this function. Well, most of the time, when the question asks you to find the inverse of the function, then you suppose that the function must have the inverse already. Then, of course, they ask you to find inverse. You know, you don't have to check the satisfy certain condition. For example, you don't have to go ahead and graph it and see if it satisfies horizontal line test or not. You don't have to do that. You just go ahead and find the inverse, because when they're asking you the inverse of the function, it means that that function has the inverse already. Okay, you just need to go ahead and find it. Okay. So the first step you have to do is you have to change. So this is the first step. Change fx to y. Okay, change fx to y. And the second step is you interchange between x and y. Okay. Then the last step will be solving for y. Alright. So as long as you do all these 3 steps here, you will get the inverse function. Okay. Let's see. Should be very easy, guys. So first step, I change fx to y, right? So fx, I change it to y, so it become what? Become y equal to 3 minus x over x plus 3, right? Okay. Then I interchange, I swap between x and y, so y become x, and x become y. Okay, y become x and x become y. The last step will be the hardest one, because if you're good at solving a literal equation, you know, you solve one variable in terms of another variable, the concept you learn, that concept you learned when you were in the intermediate algebra level. But I mean, I believe that when you solve literal equation, a lot of students still have trouble with that. So over here, we need to solve for y. You need to solve for y. I mean that this y and this y here. Okay. It means that we need to move all the terms with y together and move it to one side. It's like you solve equation. Remember when you solve for equation, you combine all the term with x together and move it to the left hand side. Alright, and all the number to the right hand side when you solve linear, basic linear equation, 1-step, 2-step linear equation. Okay, so you do the same. You treat the x over here as a number. Now you just worry about the y. You need to move everything that attached to y, that contain y to one side of the equation. Then you solve for y. So over here we need to solve for y. So what you have to do is you have to multiply both sides by y plus 3. Okay, then you FOIL it. You have xy plus 3x equal to 3 minus y. Then you see that we have two terms with y, right? We're going to move it together. So I have xy plus y. And all the terms that have no y move to another side. Okay. So basically what I do over here is I add both sides by y, subtract both sides by 3x. Okay. Then you see that there's a y over here in common. I factor them out. Okay. Then in order to get y, you just divide both sides by x plus 1. There you go. So you successfully obtain the inverse function. All you have to do now is you're gonna rewrite y as f to the negative 1 of x. Okay, x plus 1. Alright, so this is the inverse function. This is the inverse function. Okay. Alright. So, I wanted to give you another remark. That I think you should memorize this. The relation between the inverse and the original one is the domain of the inverse. Remember when I said the input of the inverse is the output of the original? So the input of fx, input or sometimes all the input we call the domain. Okay, so the domain of fx is range of inverse. It's range of inverse. Okay. And the range of fx is domain of inverse. Okay. That's why we have FO inverse of x turn out to be x. Okay. And we also have f compose inverse of f composed to f also turn out to be x. Okay. Because it's the inverse function, then the original function is kind of symmetric about the line y equals x. Okay. So make sure that you memorize all of this. This information over here is very important. Okay. Let me see if we have enough time to do another example. Let me see. I can get another example. Well, let's see. Okay. You can do another example. In this example, I want you to check if this function is one-to-one function or not. Okay. Okay. Determine if function f of x equal to 2x minus 3 is one-to-one function. Remember the definition of one-to-one function last time we already mentioned, and it is if A different from B, then f of A different from f of B, right? If x1 different from x2, then f of x1 is different from f of x2. That's the definition of one-to-one function. Okay. Then we're going to use that definition to see this function here is one-to-one or not. Okay. Okay. So call x1, x2, okay, two input of function. Alright, so we need to show that f of x1 is different from f of x2. Okay, given we know that x1 is different from x2. Okay. So we need to show f of x1, need to show f of x1 is also different from f of x2. Okay. Alright, so how we do that? F of x1, plug x1 in, right? F of x1 will be 2x1 minus 3, right? You plug x1 in there. F of x2 is also 2x2 minus 3. Okay. So now you see that, do you think that fx1 is different from fx2? It is, right? Because 2x minus 2x1 minus 3 and 2x2 minus 3, we see that this is different from this. Alright? Because 2x1 different from 2x2. Alright? Because x1 is different from x2. Okay? You see that? Because of x1 different from x2, a given. That's why 2x1 different from 2x2. And that's why when we subtract both sides, they are different from each other. Okay? So you successfully show that when x1 different from x2, fx1 different from fx2. That's why. So we can jump to the final conclusion. So fx is one-to-one function. Good. You actually, there's another way to show. You can show like this. You can show if x1 equal to x2, fx1 equal to fx2. So method 2. Okay. We can show x1 if x1 equal x2, then fx1 equal to fx2. So x1 we plug in here. So fx1 is 2x1 minus 3, fx2 is 2x2 minus 3. So you see that 2x1 minus 3 is also equal to 2x2 minus 3. Right? Is that? Because x1 equal to x3. So 2x1 equal to 2x3. 2x1 equal to 2x2. And that's why 2x1 minus 3 also equal to 2x2 minus 3. And that's why fx1 equal to fx2. Okay. So there are two ways. You can show if x1 different from x2, fx1 different from fx2, or you can show if x1 equal x2, fx1 also equal to fx2. Alright, so I think that's all for the lecture about inverse function. If you guys have any questions, just let me know. Please post your question on discussion board so that everybody can contribute and everybody can discuss about your concern. Okay. Again, all the homework you'll be due accordingly to the schedule. I already emailed you that somehow I already throw it away, and we have only one more assignment. So yeah, just try to finish all the homework. Okay. And I'll see you next time. Okay, bye bye.